morning, everyone. I'm not going to sing or dance either, and I also detest mornings. So we're going to go with that. So I'm here representing the World Climate Research Program. It's a program that is about 40 years old now, and I've just put up here a few things. We've got some core projects and research activities. These are like core research communities. And one of them you'll notice there that we're going to talk about in a minute is the Climate and Cryosphere core project, which is, I guess, the key sort of relationship we'd have with this group. And I think there's a lot of overlap, there's a lot of areas where we can collaborate through that project. I just also want to highlight, though, that we've got a lot of lighthouse activities. These are the ones at the bottom. It's a name for some activities where we're really pushing forward initiatives. Some of these, there may also be really great connections with this community around safe landing climates, around what happens if there's rapid ice loss, things like this. And I think from yesterday or the day before, we talked a little bit about the importance of developing theory and model development. We also have some groups that are working on things like model biases, right through to anything you can think of to do with model development. And I know that they would really like to work with people on cryosphere, on how you couple these models. So there's some opportunities there as well. And I'm around, come and talk to me anytime. I'm going to hand over now to our CLIC Executive Officer, and yeah, she'll tell you a bit more about CLIC.
We hate morning, but we're wearing our bright pants for you. Hi, I'm Megan Taylor, new Executive Officer at CLIC. And so we just kind of wanted to reintroduce ourselves as we have a new office this year through the efforts of Rob DeCanto and Ray Bradley at UMass Amherst. They've secured funding. I forgot to do this. Yep. They've secured funding for us through NSF and NASA so that we could have a newly staffed office. And so we have an executive director and a new communications and outreach coordinator, and my position as well. In general, our mission is to provide seed funding for international collaborations under a number of really broad topics under this sort of umbrella, including Arctic and Antarctic working groups that do with ocean and sea ice interactions, ice mass balance, permafrost carbon syntheses, sea ice physics and biogeochemistry. We also are working in mountain glacier systems, so third pole. And we want to extend more into cryospheric services, so the human dimensions of climate change. And as always, synthesizing knowledge and communicating that to stakeholders. This is a more comprehensive list of different activities that we've helped support very much in collaboration with other international project offices within the WCRP, and also crucially with groups like SCAR. And you're going to hear from a couple of those groups that are having workshops today and tomorrow in the afternoon. And so going forward into 2024, we're very much looking for input from the community in terms of research that needs funding, seed funding, workshops, meetings, and directions that you'd like to see us go. If you have any questions, there is my contact information, the CLIC contact information, and I will not direct you to our website yet because it is a hot mess, but we are working on it. So yeah, thank you.
Okay, hello, my name is Heiko Gölzer. I'm from Norway, Norwegian Research Center. And I will present one of the initiatives that is supported by CLIC. And this is the Ice Sheet Mass Balance in Sea Level Expert Group. Voila. So ISMASS is, as I said, an expert group that is supported both by CLIC, IASC, and by SCAR. And our goals are, as you can see, to promote research and estimation of mass balance of ice sheets and their contribution to sea level, to facilitate the coordination among different international efforts. So this is pretty much also why we are here presented. To propose directions for future research, to integrate observations and modeling efforts, to attract new generation of scientists into this field of research, so connecting with early career scientists, and to contribute to the diffusion of the current science and knowledge. So what we are typically doing, so that you get an impression of that, is that we organize workshops and The last big one we had was in Iceland, typically in connection with another conference, with the IGS conference. This was a 2-day workshop, and the outcome can be a paper, a review paper or something. We also have a workshop here today at 3:30 in room C if you want to join us. And today we'll be discussing ice sheet modeling across timescales. Fundamentally, the question, how do you make the link between more paleo, long-term simulations of ice sheets and projections on the more centennial timescale. So if you're interested, please come join us today or talk to us while we're here. Catherine is here, Frank is here. So yes, thank you for the opportunity to present here.
Great, there's a green button, which, perfect, awesome. So here I'm representing ISMIP 6 or ISMIP 7. We are very much a community effort. So this is something that people ask me, like, are the meeting closed? No, they are not. You can always come and join us. We do have information on the wiki that's being always up to date or trying to be up to date. We do have a Gmail, ismip6@gmail.com, which is going to become ismip7@gmail.com eventually. But anyway, the point is that we are in a very exciting stage right now where we are wrapping up ISMIP 6 activity. We gave sea level contributions from the Greenland Antarctic ice sheets on the order of 100 years to the IPCC, or to the community in general, and they came part of the IPCC report. And now we are basically in a phase, which is my 2 bottom pictures of planning the next one, right? So this is really kind of like starting again about making the sausage or making the projections. And so the 2 photos are a first workshop that happened at the UGG in Berlin this summer. And so we're having another workshop tomorrow to continue those discussions. So you can come and learn what this is like. We are, because we are, we are very tied to the CMIP process, so that explains a lot to what we do, right? If you wonder why our projections are the way they are, it's because they're very close to the CMIP process. So the timeline is evolving because CMIP 7 is evolving too. And so just if you want to find out more, I mean, it'll be a working workshop, so, but you can come and contribute. Any idea is always welcome, so.
Great. So I've been given an opportunity just to introduce you to the SWAIS2C project, which is an international effort to try to acquire new geological records and environmental data right next to the grounding zone at the Saipol coast. And involves a bunch of countries shown up here on the logos. Again, the fundamental question we're really trying to address is to really try to find evidence or get an observation that tells us what the Ross Ice Shelf and the West Antarctic ice sheet did the last time Earth transitioned from 1 to 1.5 to 2 degrees warmer than pre-industrial temperatures. So that's the fundamental goal of the project. And of course, the urgency is that we're really at that temperature now. We're rising as we speak, and as we transition towards that over that 1.5 or towards that 2 degrees, see what's going to happen to the ice sheet and what are the consequences for sea level. Now, as Reid Shearer pointed out a couple of days ago, the potential collapse of the West Antarctic ice sheet is obviously not a new thing that scientists and the science community have been wondering about. Reid Shearer back in 1978, sorry, Reid Shearer. John, you've got in my head, Reid, it's not a good thing. John Mercer in 1978 published this paper, and we've ever since sort of been trying to find the clear evidence of what actually happened during recent warm interglacials, in particular during marine isotope stage 5. We do have evidence from the far field, some of the amazing sea level records that people like Alessio Rovere, who's here in the room, and others have been collecting for a number of years, trying to determine how much sea level rose during these previous warm interglacials. This is an example of a site from not too far from here, from the Rossi Notch in Sardinia, and showing that sea level was potentially up to 9 meters higher than today. We also heard this pretty amazing talk from Sally Lau the other day about octopus and octopuses and genetics that suggest that the West Antarctic ice sheet was gone, and there were seaways connecting the Ross Sea to the Weddell Sea to the Amundsen Sea as recently as the last interglacial, at least 100,000 years ago. But again, these are hints of what was possible, not really the clear evidence. And then we've got a whole bunch of modelling studies that are out there, including a couple that I've chosen to show here. HICO, a study from 2016, showing what the ice sheet did during stage 5, and then a study by Nick Gollage and others with a different simulation during the same time interval, showing quite different configuration of the ice sheet during that stage 5 interval. So which of these is more accurate, I guess, is a question. So what we're going to do is head to the Saipol coast. There's a schematic here, a block diagram showing where we're going to drill very close to the grounding zone, where the West Antarctic ice sheet starts to lift off from the seafloor and float and become the Ross Ice Shelf. Again, trying to recover these records that show us whether or not the ice shelf and ice sheet collapsed during these previous warm intervals. We're going to use a system that is essentially shown here, a hot water drilling system that's been tested now multiple times based on the hot water drilling system from BASS, British Antarctic Survey, but we're integrating a sediment coring system shown on the left there being tested in a quarry in Wellington, New Zealand. This will be the first time we've actually put those two systems together, so fingers crossed it all works. The system itself can go through an ice shelf, but also through ice that's sitting on bedrock. We use a riser system so we can circulate drilling fluid to improve the chance of high quality recovery. The core is relatively narrow. We've designed the system to be quite light, so it's easily transportable to multiple locations around Antarctica. But again, fingers crossed it all works and we get some core to examine. We'll also be doing some microbiological studies, so collecting gravity cores, short cores from the surface, so we're trying to get that sediment-water interface for microbiological studies, but also obviously to understand what the modern environment is like today, building on a lot of the work that Hugh Horgan presented the other day from a location that's not too far from this site. We'll also be collecting downhole logging data, so geophysical data from down the hole. We have to do it fairly quickly. We don't have a lot of time, so we can't use traditional logging systems. So we've been working with the International Continental Drilling Program to use their logging while tripping gears to collect some geophysical data. But I wanted to highlight, we're going to have a crack. We're going to try to get some temperature data from both the surface and down through the hole to try to get some geothermal gradient information. So I suspect there might be some people in this room that could be interested in those data if we actually manage to get them. And I just wanted to finally put this up. So, sorry, Olaf, I didn't warn you I was going to do this, but I heard some comments yesterday about boreholes from around the continent, recognising that this one's relatively far south from a location where we don't have a lot of information from the subsurface. If we can get core and we can get geophysical data and start to understand the stratigraphy, using techniques such as this over-ice seismic acquisition capability, making it more easy to cover larger distances in relatively difficult conditions, there will be the opportunity, obviously, to take the data from the drill hole and link it, perhaps going south across West Antarctica, but also across the Ross Ice Shelf. And that the fact that these systems do now exist and are available to the community to really do some of the science that I've heard us discuss over the last couple of days. And so with that, I'll just leave this up. This is just a summary of the broader objectives. We're not just focused on the recent interglacials. Obviously, depending on what we recover, we might get some Miocene sediments, we might get Cretaceous. We really don't know until we drill. But just that we've covered our bases by including a whole bunch of different scientific objectives that could come out of this project. We've got a poster here. A lot of people from SWAIS2C are in the room, so I think there have been some stickers that have been circulated. So if you see someone with a SWAIS2C sticker, corner them, ask them if you have some questions, and keep our fingers crossed that we're successful this season. Thanks very much. And now, the last talk of the session, Kenny, if you'd like to come up and give us a presentation on rings.
Good morning, everyone. Thank you. It's unfortunate that Rob cannot make a presentation today, but let me take this opportunity to show what the SCAR Action Group Rings is doing to facilitate modelers' work and why we need to do it. I will be presenting some results that Action Group generated in the last half year, But I have to confess that the majority of them is made by their early career scientists together with some senior expert, while I'm just distributing the stickers. So if you want to help me to do the better job, take my stickers first. All right, maybe this slide is not really necessary, but I want to start from here. I'm showing the projection of the sea level rise by the end of this century for 2 emission cases. And you also see the contributions from different sources. So it's clear that Antarctica is an important player for the global sea level rise in the coming centuries, but it's not the biggest player. However, IPCC's assessment report clearly shows that if we consider the ensemble uncertainties of the sea level change, Antarctica is really dominating the uncertainty. So in other words, to predict the future better, we need to work with Antarctica, and that's why we are here in Trieste this week. When we consider coming centuries, I think there is no question that coastal region is most important. Other part is also important, but I think coastal area is the highest priority. And this is a very complicated system. You can see many elements that interplay together and many processes. And the modelers actually working to implement this knowledge to better predict the future. But what if the better topography is poorly known? We have a very fortunate to have the very updated BedMap3 FAIR database. So now we can access all bed elevation data measured in the last 6 decades. So we analyze this data to see how much radar data or bed topography data is available in the coastal regions. The histogram showing, for example, about 10% of the Antarctic grounding line has the closest data point within 1 kilometer. But nearly 20% of the grounding line has no data within 18 to 20 kilometers. And the right map showing the regional distribution of such a data availability for 3 classes, less than 1 kilometer, 1 to 5, or more than 5 kilometers. And you can see at 8 o'clock, for example, Amundsen Bay, one of the data-rich region, but still, when we see the entire region, only 50% of the grounding line has data within the 5 kilometers. So that's clearly demonstrating that we have an inadequate data set in the coastal regions. To visualize this problem, let me show the beautiful picture of Tromsø, northern Norway, where I live. So this is the picture taken from the top of the cable car, about 400 meters above the sea level. And you can see my institute, Norwegian Polar Institute, there, just 2 kilometers away. But to go this 2 kilometers, you need to go down 400 meters to the sea level, get into the water, and come up again. So that means how radar data 2 kilometers away means we have very poor knowledge about the bed elevation. I hope I made the case. Okay, we also analyzed ISMASS result together with Helene and Jenny. And then here you see the 2100 projected grounding line position. So the blue show the probability, darker blue show that more models predict the grounding line to that position, and weaker blue show that the position, some extreme models predict the retreat. And the many black lines behind it showing where radar data was collected to generate the bed topography used for ISMASS modeling. So you can see large blue part, even though there is no radar data or bed topography data at all. So better bed topography data is absolutely necessary for better projection of the sea level rise in the future. And the need for the bed topography is not only for the future, that is important to know currently, current ice discharge flux from the Antarctic ice sheet. With the best of our knowledge, we have only 3 estimates of ice discharge from the Antarctic ice sheet, and these 2 maps comparing these 3 products. And you can see that some regions have, say, 20, 30, or even more discrepancy between these 3 estimates. And the main reason of this difference is basically where they put flux gate to measure the ice discharge. One work put the flux gate at the grounding line. Another work put the flux gate is a little bit inland because there's more radar data. And one study used different locations time to time, and occasionally use eye shell freeboard eye thickness because it's measurable from the satellite. But these all reasonable choices, but that makes a huge uncertainty to estimate the current ice discharge. So one of the main purpose of the RINGS project is to measure weather topography very accurately at the grounding line. So WeatherMap3 project and RINGS project made a joint product of the contemporary grounding line positions. That is shown with red in this map. That is the case in Droni Modeland. You can see a lot of promontories, and the grounding line topography geometry is very complicated. So no pilot would like to fly along this one. I completely agree with it. So we start to simplify the grounding line, that is shown blue, and that is our target primary ring location to measure the better topography there. However, if we have the very accurate better topography and ice flux estimate at the blue simplified grounding line position, but our goal is to have the ice discharge to the ocean, that's the flux at the red port. So that means we need to compensate mass gain or mass loss between the blue grounding line and red grounding line. And to estimate that surface mass balance correction term, we borrowed the compilation of the 5 regional climate models. The left figure showing that mean surface mass balance compensation factor, and that is, say, in some cases, 10% of the ice discharge. So that is large. But also, I would like to draw your attention to the right plot that's showing the range of 5 regional climate model prediction, the surface mass balance between that blue simplified grounding line and the red grounding line. You can see huge uncertainty. So that's the reason RINGS will work not only about the better topography, but also surface mass balance, for example. June last year, we have the first workshop in Tromsø, and we have a lot of discussions, and we came up with this diagram, having the first, second, and the third priorities. Of course, this is not exclusive list, of course, but you can see that the community largely agreed on these priorities, and we try to do the best possible job to challenge everything. But that needs a lot of collaboration, obviously. So maybe you're wondering what RINGS stand for. It's just standing for the shape of the surveys we try to make around Antarctica. And then we try to put a primary ring as close as possible to the current grounding line, but we need a seaward ring over the ice shelf to see the ice shelf mass balance and the bathymetry under the ocean to see how ocean heat will be transported and generated grounding line literally in the future. But also, we need a landward ring at the slightly inland of the primary ring, because that is the region where we have the grounding line in the future. So RINGS started as a SCAR action group about 3 years ago, and we have a strong tie to SCAR and other initiatives such as Instant, WeatherMap3, and so on. But also we approach the Antarctic Treaty System and the COMNAP, that is the group of the logistics expert of the national Antarctic programs. Because we found that the logistics really limit the data availability around the coastal regions, and we feel that the strong tie and the communication with ATCM and the COMNAP is really useful. And of course, collaboration with other SCAR groups and beyond is really crucial for science. Luckily, RINGS grew up a lot, more than double since we started. And then I hope that you are interested in joining us. It's not exclusive club of the airborne geophysicists. We have modelers, ice flow modelers, satellite people, oceanographers, geologists, and so on. So please join us. And I apologize if your logo is missing. It's getting very complicated job to put all logos. Thank you.
That's not good. Yeah, it's working great. Thanks, everybody, for those really lightning presentations. I learned a lot, despite just not liking mornings. And so we will now start a regular program of scientific talks. And so our first speaker is Philippe. Would you like to come over?